Good evening, everyone, and welcome to the day three session of Getting Started with the Basics of MN, a 5-day beginner friendly program. Okay, so let us start today's session. Are you guys ready? Okay. So, before starting the session, we'll do a small recap of what we learned yesterday. We dealt with classification yesterday, which is a supervised learning uh, type of problem. So, yes, in supervised learning problem, we have two types, right? Classification and regression. And yesterday we dealt with classification, and today we are going to discuss about regression. So we learned. So what is classification? Classification is just predicting categories, right? We learned about some examples like spam email or sentiment analysis. We learned various examples, right? And also we discussed about the metrics. We have accuracy, precision, recall, and F1 score. And okay, sorry. Okay, and then we have discussed about these three classification models. We discussed about decision trees. We discussed about KNN, which is K nearest neighbors, and then we discussed about logistic regression. In what did we do in decision tree? We split the tree based on the features, and we derived a class there. We categorized, like we categorized the data based on the decision tree. And in K nearest neighbors, what did we do? We took the K neighbors around the new point, and then we decided which class it belongs to. That is KNN. Okay, and in logistic regression, we try to draw a line or like a curve to separate the two classes. I think you guys remember those examples, right? So now So this is what we did yesterday, and we also did hands-on KNN model. So let us start today's session about regression. Uh, are you guys ready to start today's session about regression? Okay, then we'll start regression. So regression is also is a problem of supervised machine learning. So regression is nothing but we are predicting the next value, the next continuous value from the data we already have. So that is regression. In classification, we predicted the category or the class it belongs to. But in regression, we are predicting the next value. We are predicting what value is there in this kind of relationship. So yeah, both of these are labeled data, right? I think you guys remember for supervised learning, both of we use labeled data. Okay, so see, so regression is just like how weather forecast happens. How in weather forecast they predict the temperature for the next day. This is what happens. Okay, like how we predict the temperature for maybe for tomorrow or day after tomorrow, like that. Uh, the weather forecast, how it gives you the temperature. This is based on regression. The forecast happens based on regression. So let us learn how this happens. Before that, I'll show you a small example. So see, you can see, right, this line is actually the relation. This line is the relation between the values. And now the machine or the system, it will try to understand, like try to derive this relation from all these already existing points, like all these orange points that are there, right? Based on these points, the machine will try to get an relationship, and it will predict this point. Like I'll show you. See, See, this is how we give the data. This is the data which we give to the machine. All these orange dots, these are the ones which we give to the machine. Okay, these are the label data. Now the machine will try to derive some relationship like this. It finds some relationship, and that is the line. And based on this line, for the next day, you can see the next point will be somewhere here. Okay, based on that relationship, because I think you're understanding how in math also we do this, right? How this happens, based on the line we are predicting the next value. Okay, that is, this yellow dot is the next value. This yellow dot is the predicted value. Okay, so this is how we can predict the, I mean, the machine can predict. The machine will find the relationship. It will derive that relationship based on the previous inputs, like the data which we give, and it will predict a value. So we'll deal with some of the examples. See, this is house price prediction. So in house price prediction, see, we can predict some house price based on where it is located, or how many rooms it is, how many rooms are there, whether it is 2 BHK or 3 BHK, or how much, what is the size of the house. These kind of parameters depend on the price of the house, right? So in that way, we can predict the house, like the house prices based on these kind of feature. This is one example of regression. And then we have temperature forecast, obviously based on all these values, maybe like the wind speed or clouds, how the clouds are there, or how the humidity is there. Based on these, we can I mean, the machine can find what is the temperature for the next day. That is temperature forecast. And then we have student score prediction. This is also one model where there are, there are parameters like how many hours did the student study, what are the sleep hours, for how many hours of, like, maybe a particular subject he study. There's so many parameters, and from based on the parameters, maybe we can predict, like we can predict how much the student can score. That is student score prediction. And then we have one more example, which is car mileage estimation. And based on the car properties like engine size or fuel type, whatever these kind of properties, also we can estimate some kind of car mileage. And then we also have delivery time prediction. I think, like, we all use Swiggy or Zomato, all these kind of things. How, after we ordered our food, there will be some estimated delivery time, right? It is based on the distance between your house and the restaurant, and also the traffic signals, and also what is the speed of the delivery agent. All these things, based on this, uh, there will be an estimated delivery time. This is also one of the examples. And then we have one more, stock price prediction. Based on, the yesterday's stock, or the trends and the trade values, all these kind of things, we can predict tomorrow's stock price also. So as you can see, in all these cases, um, we are not predicting any category or like class. We're not predicting a particular category or like particular class. There are continuous values. There is no fixed thing. Like in classification, there is binary classification, there is multi-class classification where the numbers are fixed. Like binary, there are only two types. In multi-class, there maybe, for suppose, there might be five classes, or maybe six classes, something like that, maybe 100 classes. There is some fixed number. But here we don't have like that. There are the continuous amount of values, because the value can be 20.2345 6 also. After decimals also, you can have, after the decimal also, you can have more number of values. So that we are predicting continuous numbers. So there is not no particular number of classes or categories we are predicting. So it's just continuous number, and it's an actual value. So this is what is regression. This is what is the difference between classification and regression. Okay, so now, see, as you can see, as I said, the input will be the parameters or like the features or whatever, those kind of things. Like as I said, for the maybe for For the house price prediction, the rooms, or the size, the plot area, or like for delivery time estimation, there's like the delivery agent speed and distance, the traffic signals, all these things. All these are features, right? These are the information we use to predict. Okay, these are the features. So, and then we have labels, or like the output, which is nothing but some value, which is an actual number. It's an actual number, and we want to predict. That's a value we want to predict. It's not class. In class we have categories, like that's like classification, we have categories, but in regression we have values. So we are predicting some actual numbers. Okay, so features are like some input information which we want to give, and labels are the number we want to predict. That is regression. And now let us discuss about types of regression. So, in classification, we had different types, like what binary, multi-class, and multi-label, right? So it depends on the number of, the number of, like the output is one. For multi-label, it can be more than one. See, it depends on like the category. See, binary have only two, and multi-class have more than two. It's like that, right? So based on that, we had some models. Okay, so here also for regression we have some types. Okay, see, I'll tell you about these types. So there are three basic types: simple linear regression, multiple linear regression, and polynomial regression. So we'll go through it one by one. So first we have simple linear regression. So as the name says, simple is like it is very simple, and also see it has only one feature. Okay, it has only one feature. So before going to that, so I think you guys might already be familiar with linear and non-linear relationships, right? Like you guys might have learned about it. In your math classes and all. I think you guys know about linear and non-linear relationships, right? So okay, so in linear relationship, uh, it's like a straight line. It's like, I mean, maybe approximately it can be a straight line. Okay, in linear regression, it is like a straight line. Like if you take all the points, some values, and you want to find the relation between them, if it is like a straight line, then it is linear. And if the points are like scattered everywhere around and there is some kind of curve, then that is non-linear. Okay, I think based on this only the regression category types are already also there. So in the simple linear regression, see, in simple linear regression also it's a straight line. It's a straight line. The values which are there previously, the inputs which we gave for the predicting also, the relationship between them will be a straight line. Relationship between the input and output will be a straight line. And for the simple linear regression, only we are depending upon one feature. That means, for suppose, for the delivery time estimation, we have the distance between restaurant and our home, and the traffic signals, and we have some the speed and all. For simple linear regression, it will take only one category. Maybe it will just take the distance between the restaurant and our home, and it will just say, okay, this the estimated time is maybe 40 minutes or something. It will only consider one feature. Okay. For multiple linear regression, which is the next type, it will consider more than one feature. Okay, I'll tell about that also. See, the if it is like a, see, it's straight line. Okay, and the output is like a single continuous number. As I said, for regression it is like that. And then we have, see, like this is one of the example, I think, easy for you to understand. See, predicting an employee's salary based on the years of experience. They're just years, like you. So maybe a 2 year, if the person has 2 years experience, maybe their salary is like 50,000, or maybe if they have 3 years experience, maybe like 70,000, something like that. Okay. that is just depending on one feature is simple linear regression. And then we have the next one, multiple linear regression. So here we have, as I said before, we are considering two or more input features, like the features. We are considering two or more. See, as I said before, this is also linear regression. This is also a straight line. Okay, the relationship it will be between these will be a straight line. It will be linear. So, but obviously, since we are considering multiple features, the graph will be like 3D or 3D, or it will be multi-dimensional. See, in the before, I think if you see the equation, you can understand y equals to mx plus b. So it depends. The input feature is only x. Okay, the input feature is here is only x, and the output will be y. These are the relations, the m and b. As you can understand, these will be the relations, and for multiple linear regression, you can see the output is still one. You will get one output only, right? You are like predicting only one, but see the input features are different. Here maybe for suppose if you can take that the house price prediction. See, x1 can be the size of the house, or x2 can be the number of rooms, x3 can be the location, and for the previous one, here x is just the years of experience, and y will be the salary we are predicting. So that is the difference between simple linear regression and multiple linear regression. In simple linear regression, we are depending upon only one feature. Okay, we are depending upon only one feature. In multiple linear, we are depending upon more than one feature. Okay, that is the difference. Like, see, we will take this based on the problem we have. For suppose, if if there are so many factors that will affect the output, if there are so many factors that will affect the output, then when we are selecting the model, we have to select multiple linear regression, because see, multiple linear regression depends upon multiple factors. But in simple linear regression, we can choose that when the output is not that dependent on other variables, like I mean the other factors or the features or whatever. So while choosing the model, we have to carefully analyze and select the model. And then we have the next one, which is polynomial regression. This is the non-linear part, like non-linear part. How will a non-linear relationship will be like a curve one, like a curve path, right? Not a straight line. It will be curved based on the relationship between input and output. It will be curved. Okay, so to fit the data, like to fit this data, you cannot use a straight line, obviously. So it will be some kind of curve, and obviously, so the equation can be like this: y equals to ax square plus bx plus c. Here usually we will use one feature. So that x is that one feature, that one input feature, and y will be the output. Like, for suppose, this will be useful when see, if we take the previous example of employees, or even the house price prediction. If the house is small, the price will also be this will be small, right? If the house is small, the price will be small. If the employee if the employee is less experienced, maybe he will get the salary very less. If he is more experienced, the salary will be more. So in the same way, for the house also, if the house is big, the price will be big. If the house is small, the price will be small. But if you take a temperature of a day, see, morning, it might be little less. In the afternoon, it will be very high. The temperature can be very high. In the evening, it will slowly drop, and at the night, it will be cool. Yes or no? Like, it is going like this. The temperature is going like this. So it is not increasing. Like, if it is increasing as the day progresses, if the temperature increases, then we can say it is linear. But temperature is not like that. It doesn't work like that, right? So that is a non-linear regression. That is something, a curve. Okay, that is something like a curve. So in these kind of cases, when something is not linearly increasing or linearly decreasing, curves will happen. That's what is non-linear relationship. So for non-linear relationships, we'll use polynomial regression. Okay. So here we'll understand all these. Sorry. Um, Here we'll understand how all these factors influence, like all these factors, how they influence, not just the, the feature, how everything will influence for the output. Okay, we have to analyze that carefully and select the model. So that is what is polynomial regression. Okay. So now we'll see before discussing about the models, we'll see what kind of metrics are there. So what how do we know if our regression model is good is based on the performances. See, yesterday, I think if you remember properly, uh, predicting the sunrises and sunset based on location. Okay, yeah, that is also an example. Okay. Next, we have see remember in classification, we had metrics like accuracy, what precision, recall, F1 score, right? We have these kind of metrics, but in regression, it will be completely different. Okay, it will be completely different. Classification and regression, they are not same. Obviously, they are not same. Here we are predicting a category, and here we are predicting an actual value. We're predicting some continuous numbers. So see, in classification you will check whether the prediction, the class you made is right or not. Okay, in classification you have, see, as I said, there will be particular number of classes. So so there might be 5 or there might be 6 or something. So you can just check whether it belongs to this class or not. That is what is like the metric you need to check. That's how you will check there. But in regression, you have to see how close the value is to the predicted value, how close the actual value is to the predicted value, because there are too many possibilities for the output. For classification, if there are 3 classes, then you will get only 3 output, like 3 types. And but in regression, there's so many possibilities, right? So for that case, you will not measure like the how it is predicted correct or not, but you will measure how close the actual value is to the predicted value. Like the I mean predicted value is to the actual value. So for that reason, classification metrics and regression metrics are very different. Okay, so let's go through them one by one. um, Okay, the first metric is mean absolute error. So, it will calculate the difference between predicted value and actual value. I think you can understand what an error is, right? For suppose, if even if you take, like, I think even you might have done this in physics lab or something also. These kind of metrics are there, I think, in physics lab also. See, if you the actual reading, predicted reading minus actual reading will give you the error, right? Predicted reading minus actual reading will give you the error. How far it is from the, like, how close the predicted value is to the actual value. That is the amount, like, that's the distance. I mean, that's the reading, okay, whatever it is. So in the same way, here also you will subtract the predicted value and actual value. You'll subtract the predicted value and actual value, and you'll take absolute. I think you guys know what is absolute function, right? You'll take the absolute of it. Okay, so see, this is what is mean absolute error. And you will just, after, actually, you there will be couple of inputs you give and outputs you get, right? You will just take average of them. That is why you are doing a summation and divided by n here. For each value, you will subtract it. For each predicted value, you will subtract it from its actual value, and then you will take the average of all of them, and there you will get mean absolute error. That's why mean, you are taking average of all those, like the absolute, those differences. And error is the difference. Absolute, you are taking absolute, and mean is that average you are taking for all the values, right? But you're calculating average for all the values. So that is what is mean absolute error. In a similar way, we have mean squared error. So mean squared error, it's the same way. Here you are calculating the error. Here you are calculating the error again, which means predicted value minus actual value, or like you will take like that, and you'll do square. You'll do square, and again you will take average of that. You will do the square, and you will take average of that. In the before part we did absolute. Now we are doing square. So that's how you will find the mean square error. And then we have root mean squared error, which is nothing but after doing the before calculation mean square error, you will just take the root. This is one kind of metric. Okay, so this is like yeah, this is root mean squared error. You'll just take the root. Okay, so and next we have r r square score. So it is nothing but see, it will explain how the model is good, like how the model fits the data. Is it good, like how the model is fitting the data. See, r square is like, it is different from all the three we discussed before. It will just tell like how much there is, it is varying from the, the like the target variable, the actual value by our model. So see, if the r square value, this is the formula. Okay, this is the formula, and when you will calculate the r square value, if it is 1, if it is like 1, r square value is 1, then our model is perfectly fit. Okay, then our model is perfectly fit. And then if the r square value is 0, then it is not that particularly fit. Okay, like it is not perfect. The model is not great. It's just like, what we discussed yesterday about overfitting and underfitting cases, I mean, one doesn't mean it is overfitting. One means it is correct. It is nice, the model is nice. But zero is like it's underfitting. Okay, zero is like it's not that great, the model is not that great. For suppose if you did this you do this r square to some kind of model, you did something, and you got the value as maybe like 0.0.85 or something. So it means, see, it is nearer to 1, so it is almost perfect. The model is almost perfect. And there is just like 85%, the difference in the target variable. Okay, there is like some 85% variation. So the models will use these r square to fit the relationship. Okay, okay. I mean, like, not models. Sorry, we use these metrics so that we can make the models perfect. Okay, we can use these metrics, and then we have. Okay, then we have models. Okay, some models. So, see, I think yesterday I said the types are like, see, the types of classification are like binary and multi-class and all, and they tell us like the models are like some different. Here you see, I think you might get confused. Okay, the models are also the same because we are telling the relation, right? See, for there we are just knowing the output, like. I mean, how can I say? See, they're just like output. Where we how the output is there. For binary class, there are two types of output. So that is the type of output we want. Like, there are two types, and like, see, that's like the structure. I mean, the model is like the structure, like the algorithm. Okay, like the algorithm and the data type, like the binary or multi-class or whatever it is, like the structure. So the type doesn't mean model there, but in regression we're directly telling about the relationship, right? Okay, the algorithm is used for finding the relationship. Here we can use the regression. See, the type of regression itself is a relationship between the input and output. So the same way we can implement the models also. For the simple linear regression we can use this kind of model, and for multiple linear regression we can use the multiple linear regression model. Okay, so See, let us see about a simple linear regression model. Here, as I said, the simple linear regression, obviously the relationship is linear. Relationship is linear. Okay, so which means it is like it is like straight line. The relationship between them is a straight line. And also, if I said simple linear regression, we are using only one feature, one variable. Okay, so it predicts the output. Okay, it predicts the output, and it so we'll see how we'll take an example and learn how this model works. See, I said a before example, right? Uh, Employees monthly salary based on years of experience. So you can see here. Uh, See, salary is increasing with experience. This is the relation. Okay, the salary is increasing with experience. This will be the relation. See, the model will learn the trend and predict the salaries from for new employees. So if there is a new employee, if there is a new employee, you will see the years of experience, and you will understand what will be his monthly salary. We can predict what will be their monthly salary. See, I'll tell you. Wait. See, we'll this. Let us take this case. We'll have a short data here. We have a short data. The years of experience. This guy has 1 year, so the salary is like 25,000, and this person has second 2 years, and his salary monthly salary is like 30,000, and this particular person has 3 years of experience and they have 35,000, and this particular like guy has four years of experience and they have 40,000. If you see this carefully, we can derive a relation, right? We can derive y equals to mx plus c, that kind of relation. Can anybody try to say what kind of equation it is? Like based on the data, can you guess what kind of data it is? See, x is this. X value is years of experience, and y value is the monthly salary. Can anybody try to derive an equation? Can you try? Can you understand the relation between them? Salary increases by 50,000 with year. Okay, 5,000. Okay, yeah. 5,000. Okay. But if you consider that one, uh, so if uh, if a person has 0 years of experience, what will be his monthly salary? Yeah, 5,000 per year. It is increasing. But there is some, if the answer is zero, if x value is zero, then y value will also become zero. That is not making any sense, right? See, y equals to mx plus c also should have some value, right? You guys are saying about m is 5,000. C also has some value. I'm just asking like a equation. Okay, it's nice you guys are telling about it. Okay, so let us see. See, here you can see the graph, right? We'll point one to the blue. The blue crosses are like one, two, three, and 4. C must be base salary 20. C, yeah, C will be the base salary, exactly. C will be the base salary, but it will not be 25,000. Okay, it will not be 25,000, because if you see in this example, base salary is when you will take that case when zero. Okay, zero is there. So yes, somebody kept, okay, yes, 5,000. Yeah, 20,000. Okay, I'm unable to understand what did you type. Times 6. Okay. Okay, I don't know why did you put times 6. Okay, whatever it is, less. Yes, it will be 5,000. Y equal to 5,000 into 5,000 into x. Y equal to 5,000 into x plus 20,000. Sorry, 20,000. Why 20,000? Because if you take, it will be the base salary, not 25,000 will not be the base salary. If you see this graph, you can even understand careful. You can even understand well. Look here, the blue crosses. We plotted the graph for one year of experience. It is 25,000, and then for 2 years it is 30,000. For 3 years it is 35,000. For 4 years it is 40,000. So in the same way, it is very perfectly fitting. This is very perfectly fitting. So for the fifth one, it is like 45,000. If you carefully see here, for zero it will be 20,000. Okay, if x equals to 0, then x 0 equals to what is 5,000 into x, right? 5 into x is what? 5 into 0 is 0. Y is also 0. 0 x 0 will be the salary, so it will be 20,000. Okay, so yeah, here is the equation. Okay, okay, I'm sorry here that it is printed twice. I mean, I typed it twice, sorry for that. I think remove this 2,000, guys. Remove this 2,000. Salary equals to 5,000 into experience plus 20,000. Okay, that is the equation. Remove this 2,000. It is not there. Okay, it's a typing mistake. Salary equals to 5,000 into experience plus 20,000. Okay, see, you can see here the slope is M is 5,000 and B is, or like C is the base salary, or C will be 20,000. That will be the base salary for 0 years experience. Okay, so this is how the linear regression model will be there. Okay, see, for suppose now, if randomly some person comes, see here we have only till 4 years, right? So when we give this data to the machine, it will understand predicted monthly salary 50,000. For what you are saying 50,000? Are you saying it for 6 years experience? Nitish, e-com by Nitish. Are you saying it for 6 years experience? If so, for 6 years, it will be 50,000. Based on that equation, based on the values here, it will be 50,000. Okay, see here, if we give this data, if we give the 4 years, if we give this data, the machine will derive this equation. Okay, the 2,000 is not there, obviously. The machine will derive this equation, and based on this, if we give a new point, that is nothing but, if we give new experience, if we give 5 years, then it will calculate this one, and you will get 45,000. Okay, the machine will do this thing. Okay, so this is a simple linear regression model. This is how a simple linear regression model works. And then we have one more model, which is multiple linear regression model. As I said here, we will take the case of a house price predicting case, where here the before part we are only depending upon, the data is only depending on the employee's years of experience. Okay, but that means only it is depending upon one feature. In multiple linear regression model, it depends upon two or more independent features. Okay, two or more independent features. See, it predicts, obviously here also it predicts only one continuous value, and yeah, here we have an example predicting house price using area, location, number of rooms, etc. So I think I have an example. Yes. See here there is size, there's bedrooms, and there's price. Let us just take two features so it will be easy for us. See 1,000 for this 1,000 square FT, we have bedrooms like two bedroom, and the price is this much. And as the size increased, some this in this case the bedrooms also increased. Here the price is somewhat like 5 lakhs. Sorry, I think 50 lakhs. Sorry, 50 lakhs. And then we have 1,500 square feet, and we have bedrooms again three only. The bedrooms did not increase, and we have like 60 lakhs. Okay, so can you find a relationship for this also? Can anybody find equation for this? Are you guys trying? Are you guys trying? If not, I'll say if you guys want to try, I'll just give you a little time. May I know what is that 5.2 million rupees for? I did not understand why did you put that in the chat box. I was asking you about the relationship. Like if a house is 13,000 square feet, okay. With three bedrooms, the model can estimate its price based on the trend. Yeah, yes, it can. It can, predict the price. I'm asking you guys, can you derive an equation? Okay. Let's then. I'll show you guys. See, firstly, as I said before, if it is depending on one feature, we have that one output. We are just plotting the graph for input and output, and we'll just get a normal 2D graph. For 3D, like for this for we have so many features, right? You can get a multi-dimensional graph. So I for us it is, since it is easy for us to understand a 3D graph, I'll show you this. Since there are only two features and one output, we'll get a 3D graph. Yes, that is the correct equation. I mean, that's what the equation is. I'm asking, can you guys find the values of A, B, C? It's okay, guys. It's okay. It might be a little time taking. I'll tell you how to do it. I mean, I'll tell you the equation, not how to do it. So see here you can see the graph, right? Like, see, based on the bedrooms, here you have bedrooms. As the bedrooms are increasing, you have the size is also increasing, and you can see the price also increases. Okay, so this is how the you can see the graph, right? How it is linearly increasing based on the multiple features. So after training the model, So this is the equation, right? So I was just asking you this. Here you can see, as you said, a into size. Here a value will be 2000, and here the bedrooms are like this. This is how the model predicts the equation, and this is how it will find the new value. For suppose if we give a new value, maybe the size is like 1600 square feet and the bedrooms are like 3, then it will put the values in this equation. Obviously, as I said, it will put the values in the equation, this multilinear, what is the relation we got, and based on that it will calculate the price. Okay, so I think these are the simple models so that you can understand. Do you guys have any doubts in till now about regression, or did you guys understand? Can we use sentiment analysis? No, you cannot use sentiment analysis. What is sentiment analysis? Did you attend yesterday's class? See, if you attend yesterday's class, I think you can understand. See, what is sentiment analysis? You are predicting whether it is positive sentence or negative sentence. You give a sentence to the machine. You will give the sentence to a system. Then it will predict whether the sentence is positive or negative. Okay, then it will predict whether the sentence is positive or negative. You can use that in classification. Okay, no, today is the first class. Okay. You can refer to those classes. All those videos are saved in YouTube. You can refer the day one and day two also. Then I think you can get clarity. Okay. So see, sentiment analysis is, if you give some sentence, if you give some sentence, then I'm trying to predict the sentiment analysis based on the market situation. Can you tell what is your doubt clearly? See, if you want to do sentiment analysis, then you have to do classification technique. Okay, whatever, if you want that positive or negative, that's the output. That will be the output. It's a binary classification, and see, that's classification. So you have to do classification techniques. Okay. Okay, so see, there are more regression models also. There are like SVR. SVR means support vector regression, and there are even, you can do some regression techniques based on decision trees also. So there are various kind of regression models also. But since you are just in the beginning stage, and since these are just basics, I'm just saying you all the basic models such that you can easily understand. Okay, so this is the theory part for today. We'll go to hands-on now. Um, so I want all of you to open your collab notebooks. Please open your collab notebooks. Guys, please fill the attendance form. It is mandatory. I want all of you to fill the attendance form. Uh, what I didn't understand. What about stock market investment process? Ecom by Nitish. What are you? I mean, I did not understand. Like, if you want to predict the stocks, you can use regression. Why do you need like sentiment analysis on that? Okay. I mean, if you want to do sentiment analysis, maybe you can see you can do, but you have to use classification, right? See, I didn't understand what you are trying to say, but see, if you want to do sentiment analysis, then you have to see various other features. Maybe I think you're talking about that particular thing. If you're there, you can say that it will depend upon various other things, just not, it is not a very basic model. So see, it can be helpful if you have to take various other data, you have to derive, like you have to take various data from various sources, and then maybe you can do something on it, you can do sentiment analysis. But if you're talking about basically, there is no need to do sentiment analysis for stock prices. So I think it's okay for you. If you're there, please respond. Please respond. Okay, since I think all of you opened your collab. I think you can do your own research, Nitish. It's not that a simple model. So you can do your own research and you can perform sentiment analysis. Okay, so let's start the hands-on, guys. uh, I, I think all of you opened the collab. So we'll start with loading our data set. So yesterday I said, right, the data sets, there are some default data sets. Yesterday we dealt with iris data set. It is a classification thing. It's a classification. I mean, there are so many types of flowers. The data set has so many types of flowers. So so that iris data is used for generally used for classification, and we can use for this we will use a housing data set. So all these kind of default data sets are present in a module named data sets. We will import them. So okay, from sklearn dot datasets, this is the model. We will import our dataset. For this, as I said, we'll use a housing dataset. So that the name will be like this: fetch. I think it is clear, right? The screen, the text is clear, right? Should I zoom it a little bit? Okay. So the name is fetch underscore California housing. Okay, this is the dataset name, fetch underscore California dot housing. So and then we'll also import. Okay, wait. We'll fetch this data set. We have to load the data set into this variable. We'll load that data set. So fetch underscore California underscore housing. Okay. So now I will show you how the data is actually there, how the data actually looks. So we'll create a data frame so that we can just display it. There is no need to create a data frame when you are actually making a model. I will just show you how the model is there, how the data will be there. So for that, we'll create a data frame, and this housing house dot data. Here we use this variable house, right? So we are seeing the data and the columns. For columns, we can just use this like you can just import house dot features. Here you will get all the column names. Okay, here you will get all the column names, and then I'll just now we should also have the right. Yeah, I did not import pandas. You have to import pandas, right? I think you guys remember what is pandas and numpy. For pandas, we'll use pandas for tabular data, like rows and columns. For a data frame, we are having rows and columns, right? So we are using for that. And then we'll have the target. I mean, what is target means? The output, whatever it output, we can name that as output, or like that, or you can name it as price or whatever. I'm just naming it as target, and that's what you are going to load here, get here. Then and then you're just going to print it. print data frame data underscore df dot head. Okay, you can just print it. Okay, there is a capital D here. Just a minute, guys. Okay, here it's not features. Okay, so this is how our data looks. These are just the top five rows. As I said, when we use head, we'll just get the top five rows. So these are the top five rows. And see, this is wait, I'll say you guys. This is the income, median income of the household. This is the house. This is the house age, and these are the rooms. And then we have bedrooms. Average, like these are the bedrooms, and then this is the population. Like we are calculating, and these are the locations, like latitude and longitude and all. So for now, we'll only do simple linear regression. There are so many features, but we'll select only one feature and we'll do the regression on this. So for that, we have to firstly we have to select only one, right? So for that, let us take x. X is for the input values. X is for the features. So we'll just take house dot data, which means we're accessing data now. In this data, I'm just taking only one row. I will take only one row. There are so many, right? These all are the x values. Okay, these all are the values of x. The median income, house age, average rooms, average bedroom, population, all these latitude, longitude, everything are what they are x values. But I'll just take one. I'll just put here 0. I think you guys are familiar with indexing, so you might understand this. You're just taking the first one. So I'm taking the median income. I'm just taking the median income, and then and I'll just put here. We have to reshape. Okay, we have to reshape. Why are we reshaping it? See, like we have to convert this into the 2D array. We have to convert this. I'll just type here. We have to convert this into a 2D array. For that, 2D array, we are reshaping it. We are putting -1 because we are not familiar with how many rows are there. Okay. If we know how many rows are there in this data set, see, we can only see the top five rows, but there might be thousands and thousands of rows, and we don't know how many rows are there. So you can just simply keep -1, and how many columns we want? Want only one column, and that column is this median income. See, what I'm saying is if you just put house dot data, you will get the entire all these x values except the target one. All these x values, all the rows will be considered. But we want only one value. And why are we storing this reshape is there, right? See, this is column, row and column, row comma column, row comma column. We are storing it as a 2D array. We are storing it as a 2D array so that for a particular, for the first row, this is what is the first value, first column value for the first median income value. So we're calculating in that way. So that's why we need a 2D array. That's why we need a 2D array. The machine needs a 2D array. And we can simply convert by using this reshape one. And we are putting -1 because we don't know how many rows are there. We just know, we just printed the top five rows. There might be thousands and thousands of rows. We are not familiar with how many rows are there. So we just put -1. But we know we only want one column because I'll I'll just teach you about simple linear regression now so that you can have clarity on it. That's why I'm putting one. And which column I'm selecting? I'm selecting only the median income. That's why I put here 0. This is the index. If I put 1, it will be house age, or 3, the rooms will be there. So that's why we are writing this one, so that particular values will be stored in X. Now in Y, we have to store the target values, means which the outputs. So we have to write like this: y equals to house dot target. Y equals to house dot target. So this will store all the target values. This will store all the output values. And now, so what did we do? We did the like, first we understood it. If you remember the workflow, there are five important steps. The first step, we need to understand the problem correctly, and we did understood it. We wanted to do simple linear regression. We wanted to only predict the price of the house based on just the median income. And according to that, according to our clarity of the problem, we did collect the data, right? We did collect x and we did collect y, right? So we did collect x and y. And now, since all of these are default data, all of these are already default, they are present in this data sets module, they're already very clean and good data. I'm just skipping that step because it will become too complex for you guys. But if you are taking data on your own, or you are taking from some random website and all, you have to do all the cleaning stuff. But as of now, the data is properly cleaned. I'm just giving you the basic idea. So you're just collecting the data like this. And now, what is the next step? What is the next step? We have to train the data. For training the data, we need to make sure our data is ready. Into training and testing data, I said, as I said yesterday, you have to divide your data into training and testing data. I think you guys have clarity on that, right? What is this training data and testing data? So for that, we have to import something. I'll import this here. I import this here only from uh, sklearn dot model underscore selection. So this is model underscore selection. This module has this function, like this function called train underscore test underscore split. It will help us. It will help us easily to divide the data. Okay. Sorry, there is no semicolon. It will help us to divide the data efficiently. We can take this function and we can divide our data into train and test sets. Okay. So now let us divide them. We should have some individual variables for everything. So x train, what is x train? We are taking all these median income values. We are taking the median income values. Some percent of median income values we want in train data set, and some we want in test data set. Okay. So for that reason, we are putting here an x train, and x test is for, I think you cannot see this. X test is for the test data. We are taking the features for the test data. These are the median values for test data. These are median values for train data. And then we have y train, comma, y test. These are the output values. These are the price values. Okay. These are for the y. Okay. Then now we'll train test split. We have to use this function train test underscore split. And what do we need to give as input? What are we dividing? We are dividing this data, right? We are dividing this data and this data. We are dividing this x into two. We are dividing this into two. For one x train, and for the other is test x test. So you are dividing x and y also into y test, y train and y test. So you will give x and y. So we are dividing these two. We have to give these two as input, and then test size. As I said yesterday, mostly we'll take 20% of the data set as test data, and 80% of data set as test size, 80% as some train data. Okay, we'll take 20% as test data and 80% as train data. So you have to just put test underscore size is equal to 0.2. You have to put, just you can just mention one. You no need to mention about the train underscore size. You can just mention test underscore size is equal to 0.2. 0.2 means 20% of the data will be taken from x. 20% will be taken and put into x underscore test, and the other will be in x underscore train. In the same way, in y also 20% of the y will be put in test and another will be put in y underscore train. Okay, so this will be test size. And after that, I said about random state. Random state is when you repeatedly, when you run the program again, the same 20% will be taken again. Okay, the same 20% will be taken again. That is what is random state. And you have to give this code as like 42. So this thing will take, if you run the code again and again, it will take only the same 20% as the test set and same 80% as the training set. Okay, this is we kept our data ready. Now our data is ready. Okay, now our data is ready, we'll run this. So here we understood what the problem is. So this is the next step. We did understand what we did, collect the data and we made our data ready. Now what is the next step? Model training. Yes or no? The third step is model training in workflow. So for that step you have to first import the model. So the models are also present in various modules. uh, so for this linear regression, there is a module named linear underscore model. So this is the module. Okay, and in this you have to import which model you want. Linear underscore model, you want linear regression, right? You have to import that model. So in this module you have the models and you will import in the linear model. It is a module and you are importing your linear regression. Okay, you're importing your linear regression. And now let us import our model into this variable. Model equals to linear regression. Okay, we are importing the model. So this particular variable will have that model. Okay, now what we imported the model, what we should do now? We should train the model, right? We should train the model. So for training the model, we'll use this method called model dot fit. We'll use this method called model dot fit. And in this, what we need to give? What do we need to give when training? Training data, yes or no? What do we need to give when we're training? We need to give only training data. We have to give the training features and training target values. Where did we store the features? We stored the features in xtrain, yes or no? We stored the features in xtrain. And we stored the features, we stored the values, I mean the target output values in ytrain. So we have to give that one only to the training model. So x underscore train comma y underscore train. We have to give x underscore train and y underscore train. So here, this is the very main step. Here the model training happens. Here the model training happens. Okay, so this is how the model trains. Now let's just run this. See, the model got trained. Our model is now ready. Our model is now ready. We trained our model based on the training data we have, and our model is now ready. Now, what do we need to do? We need to. What is the next step? The fourth step. We need to evaluate our model. Yeah? Yes or no? We need to evaluate our model. We need to make sure whether our model is performing good or not. How is our model performance? So for that, firstly, what do we need to do? We need to predict something, right? We need to know how our model is performing on unseen data or new data. We need to know about that. That means we need to predict. So we need to give the 20% data we have. The test data is what? That is unseen data, that is new data, right? We'll use that to predict some new target values. So that's why I'm using y underscore pred. Y underscore pred, y means what? The target values, and I'm predicting some target value. And again, you'll use model because you imported your model into this variable. And model dot, you have a function for prediction, that is predict. Okay, predict x underscore test. You're giving x underscore test because you have to predict on these what features, right? The median income was stored in x underscore test. The 20% unseen, the model did not at all see these models, right? Sorry, these features, right? This data, right? So we giving this x underscore test in y pred, I mean for prediction. And the model will predict some values and it will store in y underscore pred. Okay, that is prediction. and the prediction will happen here. um, right after the prediction, let's predict. Okay, some values we predicted and we stored in this. Now we will evaluate. The main step, we have to evaluate. So for evaluation, let's I think you guys remember, you might remember yesterday we used a module named metrics. Yes or no? There we import we imported accuracy score and all. So now we'll import here dot metrics, sklearn dot metrics. In this model, we have to import the various other metrics we have. Today we learned about all those metrics, right? Mean squared error and mean absolute error and all. We'll import them all. So mean underscore absolute error, and then mean squared error. And what did we learn? Then we also learn about f2. Sorry, R2 score. What did I say? F2, sorry. R2 score. That was F1. This is R2. Okay. Um, and then after importing, what do we need to do? We can just print them. And yes, we also learned about root mean squared error, right? What is root mean squared error? We are just simply applying root. Okay. So there is no particular thing to import. You can just take the root. So we'll print them. So print uh, mean absolute error. What is mean absolute error? This will print the text, and then we have mean underscore absolute underscore error. So what did we do? What is the formula we did? Average of all the absolutes, the difference between the errors, right? So what do we need to give right now? We just need to give y underscore test and y underscore pred, what the predicted values and the actual values. What are the predicted output values? Y underscore pred and y underscore test are the actual values. These are the actual values. Yes or no? We stored them in this. We stored them here. Here we stored them here. So these are the actual values, and then these are the predicted values. We have to find the it will find the difference between them, and then it will calculate what it will calculate the absolute values, and it will take the mean. So that's how mean absolute error works. And now mean squared error also we can do the same. Print mean squared error, same. uh, Mean squared error, and again what do we need to do? We need to find the difference between them, and it will find the square. What is the difference? The difference between actual values and the predicted values. So you will just take the actual values and the predicted values, and you will just give them to this function as you will give to this function. And then for our root mean squared error, you can just take the root. So for this root calculation, as I said, I think in the day one I said how it is difficult for us to calculate, use mathematical calculations for just small lists and all, right? Now we are dealing with here with arrays, and see, it will be very difficult for us. So that's why we can use numpy. We'll use numpy to calculate easy mathematical functions. Now I will use here numpy to calculate the square root. You can just use np dot square root, and then you will just take mean underscore squared underscore error, and then again you have to give just the y test. See, this is the same function as we did before. This is the same function as we did before. I'm just writing it again, or otherwise you can just take this one and store in one variable, and you can just write that variable name here. I think I did not import numpy. Let's import numpy here. Okay, you will import numpy so that you can use this one. And then at last we have r square score r2. So we'll take print and you can just take that function also. R2 underscore score, and you'll just put y underscore test. There is no need to write any formulas. All these will be there and their default in this functions only. Okay, you will just run. See, all these values are there here. If you see carefully here, see, it's 0.45, right? It is 0.45, which means our model is not that great. Okay, it's not that great. We need to improve our model. So we can change some parameters here and all, and we can change. And one thing, why the r square score is very less, because see here, we're just depending on one variable, right? This is some multi-linear regression, multi-linear function kind of data set. But for you guys to understand simply, I just showed you one with example of one feature. So obviously there it will be difficult. So you need to consider all the features, and you have to do this thing. So then it will be then we can build a good model. So at last, I'll just show you one thing. I think I'll show you a graph. Okay, I'll show you a graph. We'll do this fast. So for graphs and all, I think yesterday I did not show you guys about classification. But see, there is this thing called library. There is a library called matplot library. You can import that, and there are some modules in that. There's some modules, and you can import them. And there are functions like plot and those kind of things where you can plot some graphs. So I'll just show you that. So this is matplot library. You will import that library along with this thing called pyplot, where you can plot them. Okay, as I think you guys know what is as alias. You are just doing it as PLT so that we didn't type all these things. You can just do PLT or P, whatever it is you wish. So then I'll just type this plot dot scatter. So scatter, we use this for the dots. Since for here there's so many values, we'll use dots. So for that you are using scatter. You are just we are doing the graph for the what, for the inputs and outputs, right? So what are the inputs? X, the features, the what, median income, that is x comma y. And after that I'm just putting some random color. You can choose color here, color, and I'm just putting maybe red. And after that there is a label is just, for us to understand, it's just a label. I'll just put here as I'll put here as actual price, because actual price, you're plotting the prices here, right? And then we'll put values here. I'll tell you about those. And then now this will print wait, see, you can see, right? These are the values, these are the previous values, these are all the values that are present in the data set. Okay, these are all the values that are present in the data set. And then now we'll print the relation also. How will the relation be? It will be in a line, right? For this particular thing, it will be there a linear line. So we'll just plot that linear line. Plot x comma, where do we have the relation? We have it in the model, right? The model. So we have to put the model, and we have to put the predicted values. And I'm putting some color for the line. We'll put blue. And this label for the graph, like the for the line, it will be predicted price. Okay, wait. I forgot a comma here. Just put a comma after blue. Just a minute. X. Okay, wait. The color COLOR. Color is COLOR. Okay. Now this is the relation, guys. This is the relation, and based on this relation, the further future values will be detected. So this is how it will be there. And also you can use now so many. There are so many things also. I think this is how you will plot the graph. This matplotlib also has so many other functions, like you can just name the x-axis if you want. You can just name the x-axis. I'll just show you. X label, and you can just put uh, median income, because that's what the median income is, right? X is the median income. And then we'll put plot Y label, that is house value or house price, whatever. And then we can put even title also, something like this, plot dot light title, house value prediction. So you, there are so many other things also. See, you can see here the median income and house value. These are just so that these are the ones you can. There are even others like X limit, Y limit, etc., etc., where you can just for your per your preference you can adjust the graph. But the main things are these two for plotting. This scatter is for the dots part. Scatter is for the dots part, and plot, you are plotting the relationship here. So as you can see, this is how the model predicted, this is how the model used. So this is how you can build a simple linear regression model. Do you guys have any doubts about this? Okay, I waited to see output. Which one? Are you there? Yeah, okay. What do you want to see? I'll show you. What do you want to see? See, since this is a very large data, there are so many values. Uh, it will all these, they are so clumsy. Okay, I thought See, this is all for beginners, Nitish. You can develop some UI designs and all. See, this is for the beginners. This bootcamp is for beginners. So we're just doing it in collab. That I'm doing very simple models. This is very simple actually. An ML model cannot be as simple as this. There's so many complex techniques and all. So you can build a UI design model. You can build it. Maybe you can try that afterwards. First, let's concentrate on how ML is working actually. Then maybe you can understand that UI design also. Then you can implement UI design, and that will be nice to see. Is that okay? Nitish, are you a very beginner in ML, or do you have any idea? Okay. I asked you, maybe you have any idea on ML or not. Yeah, I think you can learn about it, but I'm shifting to ML. Okay. Okay, see, basically, first you need to have a idea, right? So, idea about ML, right? Then maybe you can design your like user interface, and it will be nice to see. Okay, so yeah, that's it. That's it for today. Do others have any doubts or something? You can just post it in the chat box. Otherwise, we'll end the session. Okay, all the best for you for your masters, Nitish. That's it. Do any others have any doubts? If not, we'll end the session. No doubts, right? So, so I think we'll end the session for today. Uh, Thank you all for joining for day three session. And tomorrow we'll discuss about unsupervised learning, about clustering. So do not miss tomorrow's session, day four. And yeah, that's it, guys. Okay, thanks for joining. Bye.